The purpose of this video is to introduce software HOLZ, a computer program for simulation of high-order Laue zone pattern. This is one of the components in the Landyne suite for electron diffraction simulation and crystallography analysis. You may download the software suite on Landyne website. Paper about the previous version of the software was published in Journal of Applied Crystallography in 2005. Theory and formula was presented in Journal of Material Education in 2007. Here is the launcher icon. Double-click the icon to activate the launcher. Click this button to start the HOLZ. A license dialog may pop out in case you don't have a license. Then you select the demo to continue. When a license is installed, the license dialog will not show. You directly go to the HOLZ program. The installation of license can be viewed in the video about Landyne launcher. Let's start with the functions on the menu bar first, then go to the detail with the example later. On the drop-down menu, File, first is a new structured data. Load the structured data for simulation. Next is Save the simulation HOLZ date. The last one is Exit of the software. Fine-tune. You will define a string of a lattice parameter. For a simulation, you may select the advanced formula. The simulation will take in account of a dynamic diffraction effect. Display. You may display HOLZ pattern either consist of arcs or a straight line. You may display the whole pattern, including both zero-order Laue zone and the first-order Laue zone. You may define the parameter for output such as region of interest and pixel per inch to display, and that can save to in the TIFF image mode, or a PNG and JPEG image. Index. You may adjust both index location for the HOLZ pattern and the converging beam diffraction pattern. You may convert between Miller or Miller-Blavi indices for a hexagonal system. Table. Periodic table of the elements and the table of space group symbols for both standard space group symbol and non-standard space group symbols. In the option, you can select it to show the graphic menu bar or hide the graphic menu bar. And you can change it to different styles. Also the size of the frame. Help. First one is current drive and the serial number. You need to submit the serial number to us in case that you want to get a license. And then is the version dialog. A list of crystal structures data is packed with the Landyne suite. You may use the data immediately for testing run the Landyne suite. You may also prepare a new structure data with the assistant tool, this new crystal structure template. Simply fill the required data field and then save. You can also edit the current state or transform the CIF file here. The structure file contains keyword and value. Although you may use a text editor to view the data file, it's better to use the template to create a new structure file. SVAT in the Landyne suite can be used to display the structure and to check if the structure you put is correct or not. Let's use aluminum, a default file, to get the holes patterns. All you need to do is simply click the calculate button. Now let's change the parameter and do it again to change the high tension from 200 kV to 100 kV here. The holes pattern changes. Change it back to 200 kV and change the zoom axis from 100 to 110. And again change it to 111. And you can see a threefold symmetry here. And we can also change the angles and the tilt, and also the other parameters. The software allows to match simulated pattern to experimental one, and you can use the constraint of the lattice parameter. So the holes pattern correspondent of a very small amount of change on the lattice parameter to match the pattern with the experimental one. And you can find how the lattice parameter changes. The calculation in the fine-tune of the pattern all include the dynamic effect. Now let's check the switch between the converging beam diffraction pattern and the holes pattern. This is the holes pattern in straight line, and this is the holes pattern in arc, and this is the converging beam pattern show the zero order Laue zone and the first order Laue zone. This is control the CBED patterns with index. You can also show intensity there and show the basic vector, and this is show the Laue center, control the position of the index. The index for the holes pattern only can give for a straight line mode. Tilt the index. And so the position on left and right, and up and down, or show them in without tilt mode. You may show the index for a hexagonal system, both Miller or Miller-Blavet indices, both for a plane, refraction index, or a direction or a zoom axis. You put the Miller index on the left and you play an arrow here, it will convert to Miller-Blavet indices. Or you put the Miller-Blavet index here, you click on the arrow to left side, it will convert to the Miller indices. We also provide the so-called range of interest. All the display within the ROI can be saved to a graphic file. You can save for in different mode. That's very brief introduction for the HOLZ software. Thank you for watching. Please check other videos on the Landyne suite for electron diffraction pattern simulation and crystallography analysis.